The first thing we're going to do, remember what I told you about this test. This test is going to have what? Okay, lots of word problems. So, now listen, guys. I could work word problems all day long. I like them as much as you do. Not very much. Okay? I'm just like you, too. When you bring me a word problem to help you with it, I'll automatically start to sweat just a little bit. And I pray, please, Lord, I hope I can work this one. I'm just like you, okay? So, but the more you practice, the better you get. And you do start to see some kind of, some similarities between them all. All right, so I'm going to work a problem. It's a little bit of a crazy problem, so you will need a calculator, and it does require some just general intelligence. All right? So, Sure. So this is on page 587. It is from section 8.5, which we've already covered, and we are going to do number 41. All right, so pay close attention. Are you with me? Oh, that's a little extreme. Oh, see how good y'all are? And see what a good artist I am. All right, so this is the United States of America. All right, and there's a little bitty city up here called New York. Okay, there's another tiny little city over here called Los Angeles. All right. Okay, so, and what we're going to be doing is we're going to be flying from New York to Los Angeles, and then from Los Angeles back to New York. Okay? So, I'm going to read the problem, and we're going to work the problem like they gave it to us. All right? But actually, I'm going to make you figure out some stuff that they wrote a little bit different than us, but we're going to work it like they want it to work it, and then we're going to apply it a different way. We're going to work the same problem, but I'm going to say, let's pretend you don't know this, and we're going to find it. And you're going to see how much more difficult the problem can be. Okay? Now listen, you're going to have to stay with me. It's going to get pretty involved. The numbers are a little bit crazy, but I just need you to hang with me. All right? So here's what it says. The total time in hours needed to fly from New York to Los Angeles and Los Angeles to New York. So we're talking about the total time. Okay? From New York to Los Angeles and Los Angeles to New York. We're ignoring any layovers. We're only talking about airtime. Okay? And then they give us a formula, but we're not going to use their formula. We're going to make our own up. Okay? So we're going to go from New York to Los Angeles, plus it's going to be the time it takes to go from New York to Los Angeles, and plus the time that it takes to go from Los Angeles to New York. That's going to be my total time. Okay? All right. Where D is the distance in miles, all right? We're going to call it R. They call it something else. They call it the average speed, and they call it A, but we're going to call it R. R is the rate of the plane. Now, what is that? What is it really talking about? What do we call it? Very good. That's going to be his speed. It's really just his speed, guys. Okay? And then they talk about something else. And J is the speed, or I'm going to call it rate again, of the jet stream. All right. So second period amazed me in that not one child in that whole classroom knew what the jet stream was. Okay? So first of all, let me just ask you, do y'all know what the jet stream is? What is it? That's what they said. That's, yeah. Yes, it is. Y'all, it is the atmosphere wind. It is the winds. If you've watched the weather on the news at night, yeah, which obviously none of those people had, and some people maybe in here haven't, But the jet stream comes down, usually something like this, okay? And it's really what's kind of driving our weather, right? If it comes down really low, we're way down here. If it comes down really low, then it's going to be cold here, okay? They'll say a northerner blew in, all right? And then if it doesn't, if we got a big high down here, then it'll push that jet stream back up, and it won't be very cold down here. It'll be nice, like we're used to it being, okay? So that's the jet stream. Now, tell me this. Do you think that jet stream will have any effect on my plane when it's flying this way? Why? Yeah, the wind is blowing in his face. The plane's trying to fly this way, and so he's flying in a, what's it called? What kind? A headwind. Okay? He's flying in a headwind. He's blowing against it. What's it doing to his speed? He's slowing down. I mean, I might say, hey, I'm flying my plane 400 miles an hour. But people, if I'm flying into a headwind, is my plane going to go 400 miles per hour? No, it's not. Now, when he flies back this way, what's he flying with? A tailwind. Okay? He's flying with a tailwind. Now, what's the tailwind going to do to him? He's going to make him, so if I'm flying at 400, actually I'm going to be going faster, right? Because it's pushing me too. All right? Because remember, the jet stream always blows this way, okay? From left to right. That's the way it goes. So that's a meteorologist question, and I'm not. I'm barely, I'm a mathematician because I've practiced for a long time, but I'm not a science. It's certainly not a meteorologist, okay? So I would ask them. I assume it has to do with the Earth. I have no earthly idea. I'm sure it has, yeah, the way it rotates and stuff like that, but anyway, probably has something to do with the Earth. No, I have no earthly idea. Okay, so what about, is there a formula that deals with times and distance and rate? What is it? Distance equals what? Rate times time. Okay? So if I wanted to talk about the time, could I solve this formula for time? Yeah, you could say time is equal to what? Distance divided by rate. Okay, so this is the formula that we're going to use. Now, here's what I'm going to tell you. Okay, I'm going to tell you that from Los Angeles to New York is 2,468 miles. Yeah. 2468. Who do we appreciate? No. Okay, so 2,468 miles. I'm going to tell you that my plane can fly 510 miles per hour. But the jet stream is flowing at a rate of 110 miles per hour. Okay? Now, before we move on to this working this one problem, is there any other way that we could apply all this stuff in the world? I mean, because I'm pretty sure I'm not going to fly this week or next week. Okay? Running on a track. Running on a track. Does the wind affect a runner? Yes, it does. Okay? What else? Going on a bike. Okay? Wind affects bike. No big time about that, right? Because I ride my bike a lot. All right? And it's, when you have to ride, and most of the time when I ride, I don't know what it is, but I'm riding into the wind. Brian says, when you're going back, you've got it at your back. And I go, no, it never seems to be at my back. So it's just swirling around me, and it's in my face. Okay? What about this? Let's see who recognizes this. Birds do not go that way, people. Oh, so if you're rowing a boat, right? All right, and you're rowing your boat, what's going to affect you? The current of the water. Okay? If you row with the current, you'll be going faster. If you're rowing against the current, yeah, you'll be working really hard. Okay? So, now listen. Why am I telling you this? Because the one on the test might not be an airplane. It might be. Okay? Alright. But it's all the same thing. Does everybody agree? It's all the same thing. Alright, so let's do this one. Now look, listen to what I said. The problem that they actually put in the book, it's pretty easy. You're going to look at that and you're going to go, oh, that's pretty easy. But then I'm going to take a twist on that problem. And we're going to redo it. And it's going to be a lot. You're going to say, just the one question that I asked is going to change that whole problem. Make it a lot more difficult. Okay, so let's do this one. Total time. The time from New York to Los Angeles. Well, time is distance over rate. What's the distance from New York to Los Angeles?
2,468 miles.
All right. Over, what's the rate? What is his rate from New York to Los Angeles? Oh, 510 minus, because he's going against the jet stream. He's going in the headwind, all right, minus 110 miles per hour. Everybody okay with that? That's not hard, is it? Plus, what about from Los Angeles to New York? What's my distance? Yeah, y'all, it's still the same distance, okay? But what's my rate this time? 510 plus 110. Okay, so somebody do that in your calculator. I mean, just all you got to do is punch it all in your calculator, and he'll pop the answer out for you. It's not very difficult. Ten point what? 1506. Is that what y'all got? Yeah? Okay, so 10.15, let's call it 10.2. 10.2 hours. That's how long it takes me. That's how long I spend in the air. Okay? Now, what if I said, hey guys, let's work this same problem, but guess what I'm going to tell you? I'm going to tell you that it's going to take you a total air time of 10.2 hours. Okay? I'm going to tell you that your plane can fly at 510 miles per hour. I want you to find the wind speed. Okay? Now look, people, do I know what the wind speed is? What is it? Okay, so I know what I'm supposed to get for the answer. Alright? But I just made the problem a little bit differently. Okay? So let's put this problem into play. Alright? I'm going to use this right here. Okay? And I'm going to set the problem up. What's my total time? 10.2 is equal to the time from New York to Los Angeles. Distance over rate. My distance is 2468. What's my rate? 510 what? Minus, what do you want to call it? 8x? Okay, I like X. Alright. Plus, let's do the time from LA to New York. What's my distance? 2468. And then over what? 510 plus X. Okay. So now look, we got an equation, it's got one variable, let's solve it. In order to solve it, I need to put these two things together, right? So in order to put those together, what do you have to find? What is the common denominator between 510 minus X and 510 plus X? There you go. 510 minus X times 510 plus X. Now here's where you're going to have to hang with me, guys. Okay? It's going to get a little bit involved. But if you'll keep working it with me, it'll help keep you involved and on task. Okay, so what do I do to this denominator to make it look like this? Okay, now, I'm going to need a little help, all right? So what's 2468 times 510? 1258. All right. And then 2468 times x is plus 2468x. Everybody okay with that? All right. Now what do I do to this denominator to make it look like this? You multiply by what? 510 minus x. Okay? Now look, am I putting stuff on my paper so I don't make careless mistakes? Y'all listen to me. I put that on my paper this morning and then I still made the mistake. Okay? So be careful. All right? 2468 times 510, I know what that is. Don't do it. I just did it in my head. 1002,58680. Okay? It's the same number right there, people. At this time it's minus 2468x. Now what happens? These two cancel out. So then I can just double this number, right? Somebody tell me what that is. Over, I'm going to multiply this out, okay? It's conjugate. So all it's going to do is square the first minus square the last. So what's 510 squared? 60,100? Okay. Minus x squared. Everybody okay so far? And that's equal to 10.2. I kind of dropped that off there. Okay, so now I'm trying to solve for x. Well, the first thing I need to do is get this x squared by itself. Okay, so I'm going to put this over 1. And now what can I do? Yeah, it's a proportion. How do you solve a proportion? Cross multiply. So the definition of a proportion is the product of the means is equal to the product of the extremes. That's why you solve them. Don't forget to put this in parentheses. Okay? So this is going to be 10.2 times 260, 100 minus x squared is equal to 1 times that's just this. Alright? I'm going to distribute here. What's 10.2 times 260, 100? 2653020 minus 10.2 x squared is equal to 25,17365. Now what am I going to do? Yeah, I'm going to subtract that 2653020. Alright, so these are gone. I'm left with negative 10.2 x squared is equal to what? To what? 135,660. 5660, right? Okay. Now, listen. What do I know? What do I know the answer is? 110. Am I going to get 110 exactly? Why? We rounded that 10.2 off. Okay. So it's not going to come out exact, guys, because we rounded something off. But I should be very close, right? I should be very close. Now what am I going to do? Divide by negative 10.2. Okay, so that's gone. X squared is equal to, what's that divided by negative 10.2? 13,300. Oh, that's very nice. Now what are we going to do? Square root it. X is equal to, normally we'd say plus or minus, okay, but we're just eliminating the negative one. And it's what? 115.232. And what was it? 110? Okay. Pretty close. Y'all didn't round any of these numbers off, did y'all? Okay. All right. That's not too bad, though. All right. So me just saying, hey, guys, what's the wind speed? Made a big difference in how easy that problem was to work, didn't it? Okay? All right. So let's look at today's lesson. Today's lesson is going to be kind of a play on that. This is point 8.6, and we are going to solve rational. What does that mean? It's going to be a fraction. Solve rational equations. Oh, these are going to be equations that have rational expressions in them. Now, did we just solve one of them? We did. What if I could show you an easier way to do it? Would you like that? All right. So that's what I'm going to do. Okay? Now, I'm going to tell you this. We're only going to get 2 problems done. Okay? The first one's going to be an easy one that you already know how to work. The second one's going to use the skill that I'm going to teach you to make it a little bit easier. You don't really need to use it on the first one because there's already an easy way. So the first one looks like this. 3 over x plus 1 is equal to 9 over 4x plus 5. Okay. Yeah. Now, why can I cross multiply this one, but on that problem down here, whoa, hang on there, buddy. On this problem right here, why didn't we cross multiply here? There is an equal sign right here. Yeah, it's not a proportion, guys. You have 2 things on this one side. I could put this over a 1, but I still have 2 things over here. All right? So I had to get them that way, and then we cross multiplied. Okay? So this one I don't have to get that way. It's already that way. I am going to cross multiply. Do y'all want me to? Can I just multiply it, or do I need to write it down? I'll write it down. Okay? 3 times 4x plus 5 is equal to 9 times x plus 1. Now, I'll say there will be a whole bunch of kids, and they won't want to write that step, and that's okay. I'm okay with that. Does it matter which side I put things on? No, it doesn't matter. Over here, I need to distribute, and what will I get? 12x plus 15. A lot of kids will just write this as their second step. That's okay. Nothing wrong with that. And over here, I'll get what? All right, now we want all the x's on one side, plain numbers on the other. I'm going to put my x's first. And so I put them on this side because he has the most. I'm trying to avoid a negative because I know sometimes I drop those. 12x minus 9x is 3x. Some kids will do these next 2 steps in 1 step. That's okay too. All right, what do I need to do now? Yeah, minus 15. So now I get 3x is equal to what? Negative 6. When you divide by 3, what do you find x to be? Okay, and then I could plug that negative 2 in and I could check it, right? I'd have to plug it in on this side, see what this side equals, plug it in on this side to see what this side equals, and make sure they were the same number. Does everybody understand that? Okay, and that's my answer. Okay, now I want to pretend for a second. Okay? Let's pretend that we solved this problem right here, and we got x is equal to negative 1. Now, because I have a little more experience than you guys do, I look at that negative 1, and when I look up here and start to check it, I automatically see, uh-oh, we got an issue. Anybody see it? If you plug that negative 1 in right here, what are you going to make? A 0. Can you divide by 0? No. So even though I got this solution and it was correct, when I put it in to check, it's not going to check, is it? Even if I didn't see that it made a 0, with my calculator, what's he going to say? Error. He's going to say error, and then he's going to have a colon, and he's going to say the words what? Divide by 0. That's exactly right. He's got, I mean, y'all, he's just flat telling you, hey, man, you got a 0 in the denominator. That's a problem. I can't divide by 0. It's not defined. So then this, your calculator is trying to tell you that this is what kind of a root? Does anybody remember? Oh, an extraneous solution. Very good, Jody. That's a good thing, okay? That is an extraneous solution. Remember what an extraneous solution is. It's a correct solution. I did it correctly. I got the right answer, but when I put it back in, it won't check, okay? Now, even if I didn't see it right off the bat and say, oh, man, that thing makes a 0. He's extraneous. Would my calculator tell me? Yes, he would, because he's going to say, oh, error, division by 0. It's not going to work. Okay? And does anybody remember what you do with an extraneous solution? What do you put on it? You put an X on it because it's extraneous. You X it out, people. And then what would my solution be? What is that? Very good. Empty set, null set, whatever. All right, so everybody understands. Do we scribble it out? Yes. No, you don't scribble it out because I want to see that you got, because listen to me, guys. Let's say that let's say that -1 was really the solution that you're supposed to get. And you got X is equal to 4, and you plugged it back in and it didn't check. And then you go, oh, he's extraneous. It's the empty set. Am I going to give you credit for it? No, I'm not, because it's not extraneous, people. It's wrong. The reason it didn't check is because it was wrong, not because it was extraneous. Why was this one extraneous? Yeah, he made a 0 on the bottom. He created a problem, okay? He created a problem. Does everybody understand that? A correct solution that will not check, that's an extraneous root. All right?
So a correct solution that will not check will always error the calculator.
Will always what?
Error the calculator.
Well, in these type of problems they will. Okay? In these type of problems they will. All right. So let me show you one that's a little more difficult. I'm going to skip example 2 for right now, and I'm going to work example 3. It's an easy problem, okay? But he's different. He's more like the one that the big long airplane problem. So he looks like that. 3 over x plus 8 over 5 is equal to -13 over x. Okay. Now remember what I told you. I told you there was an easier way than putting these two things together and then cross multiplying. I'm going to show you the easy way. If I could get rid of all those denominators, wouldn't that be easy? If I can make what's the problem in the whole thing? All those stupid denominators. If I could get rid of those, I could be like, oh, it's just a little equation. I can solve that. So that's what I'm going to teach you how to do. The very first thing I want you to do is I want you to take that negative sign and do what with it? Put it in the top. I'm just going to put it up here. Okay? I'm just going to put it up here. Because when you have it in the middle, then your brain has to go, well, I wonder who he goes to. See what I'm saying? Now I know where he goes. He goes with the 13. So here's what you're going to do. If you want to get rid of those denominators, then you find the least common denominator. What's the least common denominator between x and 5 and x? 5x. Y'all, I'm going to multiply everything by 5x. Can I multiply this side of the equation by 5x and this side by 5x and still be okay? Yeah. As long as you multiply both sides by the same thing, you haven't changed it. It's okay. So I'm going to multiply this side by 5x and this side by 5x. Now, this is the way I like to do it. I'm going to show you a different way to write it that some kids might like better. I don't care which way you do it, okay? I'm just telling you this is the way I do it. The first thing I'm going to do is now what did I do? I found the least common denominator, and I'm multiplying both sides by that, okay? So I'm going to put it over a 1, and then I'm going to distribute it, okay? Now look, this is what's going to happen. When I multiply this 5x by this 3 over x, what happens to those x's? They cancel, but watch. Watch what I'm going to do. I'm going to mark this one out. I'm not going to mark this one out. I'm just going to cover it up with my finger. Why am I not marking it out? Yeah, you're going to have to use it again for over here, so I'm not marking him out. I just cover him up with my finger, and what are you left with? What's 5 times 3? Boom. My denominator's gone. Now, when I multiply this 5x times this term, what cancels out? And what's x times 8? So plus 8x is equal to, what cancels out over here? And what's 5 times negative 13? Negative 65, guys. Okay? Now let's solve it. What are you going to do? Y'all, that's an Algebra 1 problem right there. I'm going to subtract 15 from both sides. All right? 8x is equal to, these are like signs, so I'll add them and take the sign of both. Divide by 8, and what is x? Negative 10. Okay? Now let me show you the other way. Some kids like to do it like this. It's the same thing. It's just a different way of thinking about it. What's the least common denominator between x and 5 and x? 5x. So they're going to multiply this times 5x. They're going to multiply this times 5x. And they're going to multiply this by 5x. They just want to see it all visually happen, okay? And then they can do the things you want to do. You can cross them both out and go, oh, that's 15. Plus, cross them both out. That's 8x. Cross them both out, and that's negative 65. That looks just like that. Okay, so it's whichever way you like. I don't mind it this way. I don't mind it this way. All right, whatever way you want to do it. Is that bad? That's not that bad, is it? Now, what's going to happen to make it bad? Those denominators, you're going to have to factor them, and they're going to be things like x plus 3, x minus 2, and stuff like that. Okay? All right, so we'll work some more tomorrow on it.